So what we're going to talk about is how do we plan a proof. So planning a proof. And this comes out of lesson 2-6. So again, this is the last new stuff prior to the test. We'll have review tomorrow, and then Friday we actually are going to take some notes from chapter 3, just because I hate wasting days, and I want to give time for you to have questions answered from the review. Okay, so I've got, actually, I think I only have 2 vocab words. Yeah. 2 vocab words. So first one is a keyword, and without it, it makes your proofs really hard. Oops. And that's the word diagram. So what is a diagram? It's a key component in a proof that illustrates the given information let's try that again. Now, there are most times where it's given to you already, but there's other times where they're giving you a scenario, and it asks you, what do you know, what's given, what are you trying to prove, what's the end result, and draw a diagram that goes with the given. So there are times where you're going to have to create everything, okay? So if you're asked to create the diagram, you're going to draw it as accurately as possible. Meaning if they tell you you have a right triangle, you're not going to draw an obtuse triangle, okay? If they tell you you're talking about an angle, you're not going to draw a picture of a segment. But you're also not going to draw, if they said you had a right triangle, you're not going to draw an equilateral triangle, because then there's more information we have from that than what's truly given. So you have to be very accurate. And then, of course, what do we mean by a proof? So geometric proof. So we call it geometric because this is something that we do in a geometry class, but proofs are used in other places as well. Okay? So it starts with given information. That's your hypothesis. And what you are to prove. Thank you, Em. Okay, then you get to use any of the tools that we've talked about. You get to use algebraic properties. You get to use postulates. You get to use definitions. And theorems to show that each statement is true. So we start with given, and we take baby step walk. Each step that we take, there's a reason that allows me to do it, and it's based on what I know. Every time I have something and I write it down, that statement usually helps me take my next step. It guides my path, okay? We generally do it in a 2-column form. But we will learn about other proofs. We'll learn about indirect proofs. We'll talk about paragraph proofs. We'll talk about coordinate geometry proofs. Most people like those the best because it's actually the math is the proof. So people like that one. Okay. So generally in 2 columns with statements on the left. and reason on the right. And we've talked about how we number a statement and its reason the same. So 1 on the statement, 1 on the reason. We also have talked about, let's see, what else did we talk about? Statement on the left, reason on the right. In the proofs that I'm going to require, that quiz number 2, that proof that had 2 reasons in 1 step, that was straight out of the book. And so that's the reason I stopped using those after a while, because they kind of give you some faulty logic. So that's why I generally will either tell you, okay, watch out, you're going to need to use 2 steps or 2 reasons for this 1 step. And the second reason generally is definition of congruence, because we're taking something that was congruent to equality or taking something that was equality to congruence, depending on what direction we need to go. So you need to really know your definitions very well. Okay. So, and again, what we're looking at is the statement 1 usually has something key idea in it that will give me reason 2 and helps me write statement 2. So we're always looking at what we have, referring back to our diagram. So we're not just barreling straight forward. We're going back and we're comparing to what we know we need, and we're trying to work our way. We make sense of what's on the left stays on the left, what's on the right stays on the right. When I'm writing my equations, they have to be in line with what it is I'm trying to prove. I want to give you, on the next stage, is that sometimes it's hard to get started. Some people have a hard time getting started, or they can start, but there's only 1 statement they get out of it, the starting. So what some people do is they start at the conclusion, what are you ending with, and what do I need to know just prior? So they kind of work backwards in a proof. So that's a good strategy to use as well. So a good strategy is to work backwards. And we've used this strategy in algebra as well. Okay, so a good strategy is work backwards from ending statement to the statement just before it. And so on. So basically what we're doing is you start with what you know. And sometimes going from the top down, you get stumped. So try from the bottom up. What do I know that I need in order to get to this conclusion that these 2 angles are going to be complementary? Well, I either need to prove that they add up to equal 90, or I need to prove that their exterior sides are perpendicular. Because those are the 2 things that I know that say you have complementary angles. So those are the kinds of things that you work with. So again, having the vocab cards, having the theorem cards, you're not at luxury just to have them and to say, hey, I did my job, I turned them in. You actually need to study them. Even the theorem cards, because you need to know what you have available to you, so you're not having to read through all your cards all the time. And everything from Chapter 2 and Chapter 1 can show up from this point on. So that's the other thing you have to keep in mind. Okay? So let's do a couple, I think I'm going to go to a new page, because actually we'll do it here. We'll do a theorem, and then we'll do its proof. Because remember, theorems need to be proved. So Theorem 2-7 states this: if 2 angles are supplements of congruent angles, and then it says in parentheses, or of the same angle. So we have 2 possibilities in our hypothesis. We have 2 angles that are supplements of angles that are congruent to each other, or we have 2 angles that are supplements of the same angle. So depending on which situation we use, that's the one we write down when we're writing out this theorem. Then the 2 angles are congruent. Now, we did this on homework. And I told you before that a lot of times what happens in our homework is we kind of do a homework problem and we get some answers, and then A couple days later, we get a theorem that supports the answer you got on your homework. So now we have something that we can conclude is true based on our experimentation. So let's go ahead. Everybody done with this one? I know that's a lot of wordies. And we're going to do this proof. Now, because I'm doing this proof, I cannot use Theorem 2-7 in the proof. Okay? So this proof is of Theorem 2-7. And how I know it is, it's based on what's given to me. Given is that angle 1 and angle 2 are supplementary. Angle 3 and angle 4 are supplementary. And angle 2 is congruent to angle 4. So remember what our theorem says. If two angles are supplements of, in this case, congruent angles, so that's what we're giving with, our conclusion is those two angles would be congruent to each other. We'll prove, not prove it. That angle 1 is congruent to angle 3. So we're going to draw our diagrams. They're going to be given to us. So that's angle 1 and there's angle 2. And here's what you can't do in a proof. Well, by looking at the diagrams, it appears to be obvious that angle 1 and angle 3 are congruent to each other because they seem to be the same sized angle. Yeah, that won't work. You have to actually give me statements, reasons that support your conclusion. Okay, so again, we can take the givens and put them all together so that they're there for me to use at any time, or I can split them up when they become important. I'm going to put them all together just because it's one less step than I end up doing. So here's my statements. These are my reasons. So I'm going to put all the givens together. So angle 1 and angle 2 are subs. Angle 3 and angle 4 are supplements. They're subs. And angle 2 is congruent to angle 4. That's all given. So what's probably the most important word that you heard in the statement number 1 that we could use to build off of? Supplementary. So what do we know about supplementary angles? Dakota. Okay, so their measures, so measure of angle 1 plus measure of angle 2 equals 180. And measure of angle 3 plus measure of angle 4 also equals 180. So that's going to be definition of supplementary angles. That's how we write that, okay? What could we do with that? What do you notice that's interesting about that statement? Kind of 2 and 1. Okay, Isabel?
Because they're both equal to 180, you can substitute angle 3 into the 180.
Yeah. Since they both equal 180, we can use a little bit of substitution, or this would be a prime one for transitive as well, because I'm taking an entire side and replacing it with an entire side. But remember, we have our option. So I know that measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. And that would just be substitution or transitive. Now you choose, you don't write both, you pick. Okay? I tend to just default to substitution, and I use transitive solely with congruence. And that way I kind of keep things straight. Okay, now what? What else do I know in this problem? Mikey?
Substitute measure of angle 2 for measure of angle 4.
Okay, now here's a problem. Nowhere in my proof do I have a measure of angle 2 and a measure of angle 4 that says that I could substitute them in for each other. All I have is angle 2 is congruent to angle 4.
So can you substitute them?
Nope. One's an object, the other one's a measure. But is there something I could do so that I could do his substitution? I think I need a little bit of a boost on something. Okay, Michael?
Definition of congruence?
Yeah, what we need to do is take the last given and change it to equality which is what definition of congruence is all about. Because now I can get step 3 and 4 to talk to each other. Before, I couldn't get the given angle 2 congruent to angle 4 with something that had an equals in it because they're not the same language. Okay, I know it seems inconsequential. It is vitally important that we get that idea down. Okay, now we can do substitution. And it doesn't matter whether you substitute in for measure of angle 2, measure of angle 4, or you substitute in for measure of angle 4, measure of angle 2. Bottom line is, I want the same angles to show up on both sides. That's what I want. So this is the hard part. You have choice in a proof. That's why when we have a really heavy test with proofs, it takes me a lot longer to grade because I have to read all of yours to make sure your logic is right. Sometimes kids come up with a way I'd never thought of before, and I have to really think about it and ponder it. And sometimes I'll even go to sleep and I'll wake up going, no, okay, no, we can't do that. And that's what happens. Often I wake up with an answer, but I need to sleep on it because I have to think about it. So that was just substitution, and that really for me is pure vision of what substitution is when I'm replacing a piece with a piece. Okay? All right, now, what could I do? What could I do? Kind of. Right. Now, we could add an extra step, and we could say the measure of angle 2 is equal to the measure of angle 2. That would be reflexive. I'm not going to worry about us doing that here. Okay? I don't think that step is that important. Curse me if other people find it important. So to do that, what I did is I subtracted measure of angle 2 from both sides. That's just a subtraction property of equality. Remember we said 5 letters for subtraction and substitution, so I know which one. I see people do sub all the time. I have no idea which one I'm looking at. Okay, now is that what the final answer is supposed to look like? No, I need to do one more step because it says you need congruence. Angle 1 is congruent to angle 3. There again is definition of congruence. So anytime I'm going from a congruent symbol to an equal symbol, that definition of congruence is going to show up, and it could show up more than once. Okay? Now, once that we've proved this, if I know that 2 angles are supplements of the same angle or of angles that are congruent, now I can use Theorem 2-8. But now, up until this point, I had to prove it. Okay? I've got one more theorem. Everybody good with this one? Yes, no. All right. Oh, Brooke's almost done. I love Brooke's studious look she has today. Yeah. She's like college student getting an A look. All right, ready? Okay, here we go. So often we have theorems that are back to back and they are very similar, but they talk about a slightly different object. So Theorem 2-8 is the same as 2-7, but instead of talking about supplementary angles, we're now going to talk about complementary angles. So the only thing that changes in this theorem is the word supplement gets replaced with the word complement. Okay, so if 2 angles are complements of congruent angles, or, in parentheses, of the same angle. So we have 2 possible hypotheses. Then the 2 angles, that's the worst "the" I've ever, sorry. Are congruent. Oh, hello, congruent. So the proof for this one is almost identical to the proof for the last one. The only thing that would change is where we said the 2 angles added up to equal 180. In our case, we'd say the 2 angles add up to equal 90 because of definition of complementary angles. Other than that, the proof is identical. Okay? So let's do something completely different. Let's do a little shorty proof. segment RT and segment PQ are intersecting. Oops. At point S, so that the length of RS is equal to the length of PS, and the length of ST is equal to the length of SQ. Our job to prove would be that the length of RT is equal to the length of PQ. So we have a diagram. We have two segments. We have segment RT and we have segment QP. We are told from here that the length of, and the intersection point is S. We're told that the length of RS is the same as PS, and the length of ST is the same as the length of ST and RS and SP and ST and SQ. Sorry, I lost where it was. Okay. So what do you think we're going to use to help with this one? Looking at those diagrams. I'm trying to prove that RT, the whole segment, is congruent or is equal to, its measure is equal to the PQ, which is the length of that whole segment. So what does that look like, Mikey? Yeah, it looks like we're going to end up using segment addition postulate. So when I'm planning, I'm kind of looking at my diagram and thinking about, all right, I need to pull out all the stops on all my segment things, and I've got two little guys add up to equal a big guy. It kind of looks like I'm going to be doing segment addition postulate. So this is kind of the crazy one. Okay, so I know these two things. RS is equal to PS. ST is equal to SQ. That's my given. But what I want is RS plus ST to equal PS plus SQ. What have we studied that allows me to do that? How do I get this equal to this? Okay, Dakota? Pardon me? Not transitive property. Georgie? Nope, it's not division. It is a property. You guys are on the right track. In fact, it was the first one we talked about. This is that second case of addition property. Left sides of two equations add together equal the right sides of the two equations. We don't use addition property of equality like we do in algebra where we're adding the same thing to both sides. We use this version of it a lot more. And then that's when we're going to bring in the segment addition postulate, where the length of RS plus the length of ST equals the length of RT, and the length of PS plus the length of SQ equals the length of PQ. That is the segment addition postulate. Now notice I wanted RT to end up on the left in my final and a PQ to be on the right, and that's all my stuff has been leading that way. So I can substitute into 2 what I found from 3, and I get RT is equal to PQ, and that would be transitive property of equality or substitution property of equality. I'm going to say substitution. Okay? All right, good luck.